Good. That sounds like a good use of our time. All right, how far did I go in the video? Okay, what labels do we have in here? This is half a circle. Okay. One. Marvelous. And then we know the arcs because these are central angles. We know the arcs are the same. Okay. Okay. All right, so we're going to do example 4 and 5. So the arc measure for ARG. From A to R to G. ARG. What's the arc measure for ARG? Anybody? ARG. It's 90 plus 159.
You're the first person that has done it.
Okay, 249. Okay. So we're going to do 249 over 360 times 2 pi 6. Okay. 249 over 360 times 2. Times 6. Okay, so the instructions said to use exact terms of pi, so you can do 8.3 pi, or you can do this in fraction form and do 83 pi tenths. Which one do you guys want to do, decimal? Okay, now this is a good decimal. Listen carefully. This is a good decimal because I'm not rounding. Okay, the only reason I'm doing a decimal with a pi on this one is because it's not a rounded decimal. This is an exact decimal. Okay, that's why it's not making me uncomfortable. So I've got this, and then this is a length. So I've got centimeters as my units. Okay, and then what would I do for sector area? Pi 6 squared. Okay, so 249 over 360 times 6 squared. I'm not typing the pi in, so that's 24.9 pi centimeters squared. Okay. Now, number 6 is related to number 4, so we might as well do number 6 now. It says, what is the approximate length of ARG rounded to the nearest thousandth? So to find the approximate length, we're going to take the 8.3 pi, we're going to plug that whole thing in the calculator with the pi, 8.3 and the pi. Everyone know how to get the pi on their calculator? Second up arrow. They call that a caret. I don't, because it looks, I don't know. They call that a caret. That little up arrow, they call that caret. I don't know why. I don't know. Nearest thousandth is 3 decimal places, so we got 26.075 centimeters. And I'm just gonna, since these are notes, I'm just gonna write that this was 8.3 pi, so that I am not confused later when I look at my notes. Okay. All right, so that one is good. All right, AR. AR is how many degrees? 90. Okay, so we've got 90 out of 360. 90 times 2 pi 6. So 90 out of 360 is what fraction? Yeah, 1/4. We don't even really need our calculators for that. We can tell that's 1/4 of the circle. So 1/4 of 12 pi is 3 pi centimeters. And then 90 out of 360, so 1/4 again, pi times 6 squared. So 1/4 of 36. What's 1/4 of 36?
Oh, I got you. Wait, don't tell me.
9 pi centimeters squared. Okay. Was somebody snorting? And it wasn't even like a solid snort, it was like a snortle. It was like a cute little snort, like a piglet snort. Not a pig snort, not like a snort snort. It was like a little, was it like a pig snorts and a piglet snortles? Anyway. All right, what was the area of TG? I'm going to be honest, I did not watch my own notes this weekend. It was, wait, it was what? 2.1 pi centimeters squared? Okay. Okay, so if we were to go, yes. Yes.
This one's the area. Wait, 21 is 2.1.
2.1. Okay. Sorry, I did not watch the notes, so I'm trusting you guys. 2.1 pi? Okay, so now we need to plug it in. Is that what you were talking about? We got to plug it in now? You were telling me the answer. Is that what you're doing? So we were looking in the far right column for TG. So example 1, far right column. Yeah, we were going back to use something from the video, and I just don't have that written down. Okay, so this is going to be 6.597 centimeters squared. Would you guys agree? Yes? Yes? Okay. All right. How do we feel? Tired. That's a valid feeling. I support that. All right. Okay, let's put our notes off to the side. Let's look at the assignment, because these problems were pretty straightforward. Not every problem on the assignment is, okay? Okay, so the first little section on the assignment, let me zoom out if I can find my little remote. This first little section acts almost like a warm-up and is kind of review. So 1 through 6 is not necessarily arc length and sector area. That is kind of a review using the idea of central angles and arcs and things like that. So 1 through 6 is old stuff from before today. Let's move down to 7 through 12. So if you have a marker or a pen that is colored or something like that, that might be beneficial. I'm just going to talk through a little bit of what you are calculating for this. So for number 7, 8, and 9, it says to write the first 3 lengths in terms of pi, and round the second 3 in terms, so to the nearest thousandth. So we're going to write that off to the side, actually. So, yes. No, you are. I'm just not going over them because they're review. So for the first 3, I'm going to kind of draw a little line through here so that we understand the instructions. So draw a little line. Okay. And above the line, you're going to put pi. And below the line, you're going to put decimals. So the first 3 are in terms of pi. The second 3 are the decimal answers, okay? And that's because I want you to practice both types of answers. All right, so in the problem, you are finding the length of AB. So if you have a color, a pen or something, you're finding this length right here. AB, AB, we're finding this length from A to B. And in each of the problems, they give you a degree measure and they give you a radius. AB. I don't feel like tracing those because they're long. Okay. So let's go ahead and just show our work, what would be important. So remember, I'm just going to remind some of you guys who like to not show your work is that since I have answer keys up, you do have to show your work because it would be easy for you to go through and just copy all the answers and go really quickly. Okay, so I do expect you to show your work always for all these problems. So the work that I want to see for these is how many degrees are we doing out of 360 for number 7? 80. Okay, so we're going to say 80 out of 360 times what? 2 pi. Now, is that a diameter or is that a radius? That's a radius because that's half the circle. So 2 pi 12. And since these answers have to be in terms of pi, are we plugging in the pi to the calculator or not? Not. So the way that I like to say if you are struggling with whether or not you should plug the pi in the calculator is either the pi goes in the calculator or the pi goes on your paper. It only does one, okay? So here, these answers, the pi is going to go on your paper, which means it does not go in the calculator. Does that make sense? For the other 3, the pi goes in the calculator. That means it does not go on your paper because it's decimals. Okay, so it either does one or the other. Yes?
So for 10 through 12, does it matter if we put it in equation or if we use that and then multiply that and answer by pi?
It does not matter which one you do. Okay. But it does have to go in the calculator so that your answer is in terms of pi. Or so that the answer has the pi calculated into it. So we're going to do 80 out of 360 times 2 times 12. We are not putting the pi in the calculator because we are writing the pi on the paper. Now, this decimal answer, I would have to round to write the decimal on the paper, and so I'm not going to put the decimal answer, I'm going to put the fraction for this one. So I'm going to write 16 thirds pi, or you can write 16 pi thirds, it does not matter, and then centimeters. There's my answer. Okay. So showing my work, writing my answer. So for the next answer, if you wanted to write this and then plug the pi into the calculator to get the decimal, you could. Or if you just wanted to write this and then plug the whole thing in to get the decimal, you could do that. Yes.
If our calculator puts it out to a fraction, we just leave it like that.
Well, for 10 through 12, your calculator would not possibly give you a fraction because pi is an irrational number. So once you plug the pi in, it will not be able to give you a fraction after that. So for these ones, for 7 through 9, because we didn't plug the pi in, we could get a fraction. But when you once you plug the pi in, there's no way you could get a fraction. Yeah. Yeah. Good question. Yes. Uh-huh. Yep. For 11 through 12, the arc that you're working with is the whole big, all the way around. Yep. And then the same thing for number 12, the arc that you're working with. They showed you that the part you're not working with is 90, but the part that you are working with is the whole rest of it that is not 90 degrees. Okay, let's look at the next page. So the next page has them shaded in. So we are not working with arcs anymore, we are working with areas. So shade, 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 shade. We're going to find the area. Shade, shade, shade. So that's how you can tell from these types of pictures if you're finding the arc or the area. They're either shaded or they're not shaded. Again, we're going to divide these in half. And the first 3 are going to be in terms of pi, and the second 3 are going to be decimals. Okay? So I don't want to do any more of these because these are exactly like your notes. So these are going to be pretty comfortable. We're going to jump down to number 19. Number 19 is a different type of problem than your notes. So number 19 is where I want to do one of these together, just in case it would have messed with your brain. Okay? All right, so look at the instructions for number 19. How is that different from the notes? Yeah, so not the circumference, you're getting the yeah, they're asking you to find the degree measure of the arc, and they actually gave you the length of the arc. So we're going backwards, okay? So we're going to say the length of the arc, and I don't know, we'll say, okay, here's how they write it. They say the length of the arc equals the measure of the arc divided by 360 times 2 pi r. There's your formula. Does that make sense? So the length of the arc equals the measure of the arc. Do you guys see the difference between those? The measure of the arc is a degree measure. The length of the arc is not. The measure of the arc is a degree measure. The length of the arc is not. Do you see the difference in how those are written? The measure of the arc is a degree measure, and it's got an M in front of it. The length of the arc does not. Okay, that's written as just a length, as in like a length of string or something like that. That's written in centimeters. The measure of an arc is written in degrees. That's the difference, okay? And my 360 should have a little bubble, 360 degrees. Okay, so let's go ahead and plug in the information that we know, and then we'll solve for what we don't know. So we know that the radius is 12. We know that the length of the arc is 12.56. So I'm going to say 12.56 equals the measure of the arc. Do you guys want to put an x there, or do we want to write measure of the... Okay, so we can go ahead and do x over 360. All right, what do you guys want to do to solve for the x? Yeah, multiply by 360 to the other side. We'll get rid of the fraction, and it will make this a little bit less intimidating. So we can multiply by 360, multiply by 360. So I've got a 12.56 times 360, which is going to make that a lot bigger. Yeah. So we got 4521.6 equals x times 2 pi 12. Okay? And then what should I do? Okay, divide by 2 pi 12. Okay, now when you type in divide by 2 pi 12, we're dividing by 3 things, so we have to be careful. Now, if you type into your calculator 4521.6 divide by 2 pi 12 like this, if you type this in, you're going to get the wrong answer. Because what your calculator is going to do is it's going to divide by 2, and then it's going to multiply by pi, and it's going to multiply by 12. Okay, that's what your calculator does if you type it like this. So if you want to type it correctly, you have 2 options. You can do 4521.6 divided by and put the 2 pi 12 in parentheses like that. That's one option. Or if you don't like parentheses, you can type it in like a fraction. You can do alpha y equals and do 4521.6 and then do the 2 pi 12 on the bottom of the fraction. Does that make sense? So you can do parentheses or you can type it in like a fraction. Those are your 2 options. All right, so what did we get for x? Okay, so, and typically these are going to be written in such a way that they're trying to get you to a certain whole number for a degree measure that's like a nice number. So what degree measure do you think they're trying to get you to? They're trying to get you to 60. So we're going to say that the measure of AB, arc AB, is approximately 60 degrees. That is okay on a test. It is also okay if you put 59.970. Yep. I would take 969 as well. So 970 is rounded. 969 is what we call truncated rounding. Truncated rounding is where you just take 3 decimals and you cut them and you don't care about rounding. So truncated rounding is I cut the decimals off and I ignore what teachers taught me in the past about rounding up or rounding down. I just cut. Does that make sense? And truncated rounding is fine. All right. How do your brains feel? Okay. Would you like to try another one of those? Okay. So on the next page, so we have another one. We can do another arc length one, or we can do a sector area one. Okay. So we've got 22 through 24. Which one would you guys like to do? 24? Let's do a big area. Okay. So we're going to say, I'm going to say the sector area equals the measure of AB divided by 360 times pi r squared. Okay? Over here? Is this good? You tell me when. Yeah, blinds. Don't be dumb, blinds. Let's get that sunshine out of here. Gross. Is this better? Okay. Marvelous. She's putting the blinds the other way. All right. So here's our drawing. Okay, so what should we do? Oh, 226. Times pi, and then 9 squared. Okay. And then what should we do? Yeah, it doesn't matter which one you do first, but if you don't like fractions and you want to fix the fraction first, that's a great idea. So we could do times 360 first to fix that fraction. Okay. And then what should we do? So you can divide by pi 81 or pi 9 squared. They're the same thing. Just depends on if you type this or not. Okay. So you can type it in like a fraction, or you can just make sure that when you do this that you have the bottom in parentheses. So this one, we can tell what angle it's getting to, but it's not as close to the whole number angle as the last one was. right? The last one was very close to 60 degrees. This one is not as close to the whole number angle, so this one I would probably feel a little bit more comfortable writing the decimal. But we can tell the angle was supposed to be, what? 320. So I'm going to say, I'm going to write it up here where I have more space. So the measure of arc AB is approximately 320 degrees, or we can do 319.725. On a test, I would be very specific about which one I expected you to say. I would say rounded to the nearest whole degree or 3 decimals or whatever. All right, the easiest problems I think that are on here are 1 through 18. The more difficult problems are the multiple choice ones. So I would say warm your brain up by working on the ones 1 through 18. Don't spend too long on those. Once your brain feels warmed up and you're like thinking in math class, switch over and start trying the multiple choice ones. Those are the more difficult ones. And don't struggle for too long. Call me over if you get stuck, okay? And if we need to do some of those multiple choice ones as a class, we can do that, okay? My recommendation for the multiple choice ones is to write out the formula that you need. So write out the surface area formula or write out the arc length formula and then plug in what you know. That's my recommendation for the multiple choice problems, okay? Did everyone hear that? Multiple choice formula or multiple choice problems, write down the formula, plug in what you know. That's my recommendation for those. Again, just because they're multiple choice doesn't make them easy. I pulled them because they are like EOC problems. Does that make sense? That's why they were not very nice. Okay? So go ahead and get started. I'm going to work on the answer key, get it on the back wall for you. Yes? Oh, yeah. Also, keep in mind, quiz tomorrow. Everyone see that? Quiz review, quiz tomorrow. I'm going to try to get that ready for you guys so that you can work on it tonight if you choose to. Remember how that works is we maybe start it the night before because half a class is usually not enough time to get it done. Yes? No, not a test. Quiz. Tomorrow. So we have a quiz tomorrow. We have a test. I don't remember when the test is, but you can use a cheat sheet on the quiz. You can use the cheat sheet on the quiz. I would have it, yeah. Yeah. You don't need it as badly as you'll need one on the test, but it would still be nice to have. Okay. Any other questions? Okay. Go ahead and get started.